This question asks, consider the reactions below and select the false statements. So we kind of have several things going on here. We have multiple reactions to consider. We're given the starting materials and the reagents, but we need to predict the products. And then we have some true false statements that we're going to have to answer about these reactions. And a lot of the questions kind of center around kind of what's happening in the reaction. And then one of them is centering around the products that are formed. So definitely we'll want to draw out the products to kind of help answer the true false statements. So let's go ahead and think about what products we get in each case. For reaction number 1, we have HBr. And HBr is going to proceed through a carbocation intermediate. The first step is going to be proton transfer to kind of make that carbocation. So always draw the carbocation out. The key reason for always drawing the carbocation out is so that we can consider whether or not a carbocation rearrangement will occur. In this example, we don't have to worry about a carbocation rearrangement because we have a tertiary carbocation and there's no rearrangement that'll make it more stable. So from here, then we have to think about what's the product going to be. So the bromine atom is going to come in and attack. And our product is going to look like so. It is an achiral molecule because the bromine is attached to a carbon with 2 methyls. So we only make that one product for reaction number 1. For reaction number 2, we have oxymercuration demercuration, but notice our nucleophile is an alcohol instead of a water molecule. So that'll change our product from an alcohol to an ether. Let's see what we will get. This reaction, like the first reaction, is Markovnikov regiochemistry. So we're going to add the methanol to the more substituted carbon. And it's also going to have anti-stereochemistry. So it doesn't hurt to kind of keep in mind what our regiochemistry is. So Markovnikov regiochemistry, anti-stereochemistry. The stereochemistry is not super significant in this example, except for us to recognize, that in general it'll have anti, but only if you're creating a new chiral center. In this case, I don't believe that we are. We're going to make this as our product. Again, because we're adding the methanol to the more substituted side and the hydrogen to the less substituted side, we're only making one single product, especially since the carbon that we're adding to is not chiral. The last example is the same starting alkene, and this reaction is the halohydrin formation. So notice that we have water present with the bromine, and that's significant because it's a nucleophilic solvent, and so it will come in and attack the bromonium ion that we create as our intermediate in this reaction. So in this case, we also have Markovnikov addition of the water to the bromonium ion. So we're going to make kind of 2 products in this case because the bromine is going to attach to a carbon that will become chiral. So our 2 products are going to look like this. We'll have bromine here that can be wedged. And then we can make the enantiomer where the bromine is dashed. So 2 possible products for reaction number 3. The reason why we get enantiomeric products is because the alkene is flat. And so we can form the bromonium intermediate on either the top face or the bottom face. And so that's why we get 2 products out. If we'd created new chiral centers in reaction 2, for example, we would have had a similar situation. So now that we've thought about the products and the reactions that we have going on, let's take a look at our statements. So statement number 1 says both reactions 1 and 2 proceed via a positively charged cyclic intermediate. The key here is that that statement says cyclic. So only reaction 2 and 3 proceed through cyclic intermediates. Reaction 1 does not. As we stated earlier, reaction 1 goes through a carbocation intermediate. It is positively charged, but it's not going to be cyclic. So this statement would be true if it said both reactions 2 and 3 proceed via a positively charged intermediate. But since it doesn't, this one's false. Statement number 2, reaction 1 will undergo a carbocation rearrangement. When we took a look at this, we decided that it would not undergo rearrangement. It possibly could undergo a rearrangement, but this question and this statement is referring specifically to the reaction that we have in 1. And this specific reaction with this specific alkene will not undergo rearrangement. So we would say that this one is also false. The third statement says reactions 2 and 3 will each produce 2 products. So in this case, we have to kind of look at the number of products that we formed in each reaction. So we saw that in reaction 2, we only make one product, whereas in reaction 3, we make 2. So this one is also going to be false because reaction 2 only makes one possible product. So the answer to this is that all 3 statements are false. And so we can select E as our answer because E recognizes that 1, 2, and 3 are all false.